Hello everyone, I'm Xiao Gang. In the previous section, we refreshed this, specifying this path to refresh all files. Then in this lesson, we will implement the stop waiting and remove waiting. We need to move this down here because our binding is so large. You will notice that we bind it this way. So when clicking here, we need to declare the binding first. Before declaring the binding, we first write a method. This method is used to extract. This method is used to extract. This method is used to extract. We can hide this part here because we have already written it. We hide it. This. So its function is, it is actually mainly used to refresh the files under the current directory. So how does it refresh? First, after it finishes executing, you can use this. This is a refresh. Actually, it is a refresh. The function signature is still the same as ours. It needs to capture this path and this. Zhang Yin's folder. First, we need to get the string under this path. Then we prepare an array, iterate through all the file names we found. And here, we still use wildcards to find them. After finding them, we clear our scroll box. After clearing, we do a loop to add them. And here, actually, is the same as the code here. The same as the last part of the code here. Essentially, we just extracted it out. Yes, because we have a path judgment earlier. At this point, it actually doesn't need to perform this path judgment anymore. Okay, we don't actually need to keep this return value here. But the reason we wrote it down is because we might want to make a refresh button. So here we still write a standard anonymous function that can be bound to this button. Lambda, right? So this function is for refreshing. Now let's write the two lambdas for adding and removing. Okay, let me paste the function signature first. Okay, we are adding, right? Okay, our removal. Okay. Then what we need to do is first, at the very end, we definitely need to have this return that it has been processed. Then we need to paste this over and paste it here. Pay attention to the semicolon here. Pay attention to the semicolon here. You see, this is essentially a chain of calls. It returns this reference. So that's how it's done. Okay. Actually, when we were working on the control flow, that flow was also a chain branch formation. Right. Okay, so this binds these two functions to these two buttons. Next, we need to write this add. And this, let's take a look at this. Right? Let's remove this carriage return. Let's flip it, a function to add and remove a prefix. But you can implement more features, and that's perfectly fine. Because our requirement here is to add a batch prefix to files. For example, adding the characters UU5. So our requirement is like this. So we designed it this way. Then we type a character here. That is, we start adding this prefix here. Let's copy this character. Okay. Alright, let's start adding this prefix. Then first, we know the name of this current prefix. It is input contents. The input contents input box. Then we get the input text if this text is empty. If it is empty, we will have a return as already processed. We will have it do nothing. Then next, get the path of our current folder after obtaining the path. We traverse the folder. We don't need to recurse into subfolders. If you need to, you can recurse. But here we obviously don't need to. One go to our file manager. Like this through it. Then if you want to recurse, actually, there are some recursive folders and functions and methods here. You should take a closer look at this class. It's about file handling. Okay, then we find all our files. We put them in. Next, we will traverse the files we have found. Because our main goal is to ensure that our log is relatively complete. So we iterate through it. We have found some files. Then after the iteration is complete, at this point we need to read the original file name and then move it over. Just increment and move it over. So that's how it's done. I will continue iterating. We separate them this way to make a distinction. It seems like these could be combined here. It probably won't go down either. Yes, this part mainly does it twice. This print a log, then this is equivalent to our new name. Then we prepare this one. You see this land. I think this ln should be target. Yeah, this name should be changed to target. Then the meaning of this function. This move is actually to move this file. That's what it means. Then set the destination of this move and also the source file. Then we need to concatenate the path here. This configuration path is what we set up earlier. After we concatenate it, we go from this path at the back. Move it to this path. We are done. After that, we need to use our lambda. This lambda is the one we just wrote. Let's refresh our info box. That's how it's done. So this is how we add this prefix. Then how do we remove the prefix? First, let's add a log. But to make it easier to distinguish, okay, this is removing the prefix. Similarly, we get this prefix name. If this prefix is currently empty, then we won't do anything. Okay, same as before, get our folder path. Then we traverse the current folder, put it into our string. Into the tier, we put it into this tier. This step is the same, no problem. Okay, same. We take all the files we traversed. We print them out. We put it here. Okay, we print it out. Next, we start reading the source file. This is how we do it. Still the same broken loop. Need to read it. Then this door key. We let BUA move. If we successfully remove this, remove the prefix from the front. If it is successfully removed, then we will perform this target operation. We will read out this string. If we did not remove it, then we skip this file. We switch to the next file name. Then after all the work is completed, we do this refresh. Okay, so for our entire feature, it's actually already done for you. We can compile it here. There shouldn't be any issues. Okay, so we might need to prepare a folder here. Let's just put it anywhere. Create a folder and try to avoid any Chinese characters to prevent strange problems. Let's just paste it. Okay, and then we'll launch our program. Let's start it. Okay, then click Open Specified Folder. Go back to our desktop. Open this folder. You can see. Then we add a prefix to it. We'll give it xg. We add the prefix. You can see it has already changed to xg. Then we can take a look here. You will see that everything has become xg. Then we remove it here. No problem, right? We could originally say UE5. Then we call it Learning from Basics to Advanced. Then we add a prefix. You can see. Then if, for example, you also want to add some sequence numbers, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can do it like this. No problem. We remove it if there isn't any. We just can't remove it. We can even remove 2 A's. You can see. Add an A. Okay. So our specific renaming requirement is complete. Then you can expand on this basis. For example, if you want to insert a name in the middle or something, then you can perform such an operation. But there will be a problem. We can set a breakpoint here. For example, let's set a breakpoint here. Then we launch it. Then we test here. We add 1. Then you will find that this game3 comes in. This is very good, but there is a problem. This is done in this frame. Then we can take a look at our stack. This stack is much simpler. You can see the slide occasion place. It comes to the top. Actually, this is how it handles it here. You can see pump message is here. Actually, it is here. Here, the thing that pump message processes. Right, and here it is actually within one frame. Then the time for this frame will be very long. In fact, it doesn't quite fit our real-time rendering workflow. Right, so how should we further optimize it? Moreover, we have written all the logic into the slate. This slate is actually very bloated. So we can write this function name outside. Write it outside. Writing it below here is also fine. We write it all into one constructor, and this constructor is already over 100 lines. Generally speaking, if it exceeds 100 lines or has more than a few dozen blueprint nodes, it needs to be optimized. Okay. However, using this for basic learning is a very good example. In our next lesson, we will explain our computational code and how to design an optimization strategy for contention. Okay, that concludes this lesson. Thank you, everyone.